Hi everyone, my name is Prasad Kintali. I'm a data engineer. During the project I have been working on, I have to create a change data capture from a source database to a target database, which is whatever the changes we have seen on the source database, they're supposed to reflect on the target database. So I have been using Debezium and Kafka. These are open source tools, and the Postgres as source database to do this mini project. I have split this my use case into two parts. One is capture the changes into Kafka topic. That's part one, and consume the Kafka topic changes into target database. Target database. That's a part two. This video is mainly concentrating on the part one, which is capture changes from PostgreSQL. I'm using a source database to Kafka topic. Coming to the next slide. So this is the basic architecture of a data stream using Kafka and Debezium. So the source database can be anything: Postgres, MySQL, DB2. But for my convenience, I'm using PostgreSQL Server. So we need to make the PostgreSQL Server database, whatever we are using, is fully replicate that we'll see later, so that the transaction logs can be logged into a transaction log. So and the Debezium will capture the transaction logs and notify to its clients. In this case, it's Kafka. So once we have the changes in the Kafka, we can consume the changes into multiple consumers or a single consumer and push the changes to wherever we want. In my case, I want the changes to be pushed to a target database. So as I said, I have split this use case into two parts, and the part two is coming in the next video. And the part one is this one: consume the data changes from Postgres to a Kafka topic. So I have split this one into 5 steps. Let's go to the first step. So basically, we need to compose a Docker image with multiple things like Postgres, Zookeeper, Debezium, and Kafka images. PGAdmin is completely optional here. PGAdmin is basically a GUI interface to handle the Postgres database. So let's start with the step one, composing the Docker. So I'm already in my project folder. So type Docker compose. Sorry. Usually it'll take quite a bit, but as I have already built this one, it'll be done very quickly on my part. So it's done, and let's see the Docker image. The container have multiple images like Zookeeper, PGAdmin, Postgres, Kafka, and schema registry, and Debezium. So these are the images, but let's go back and see why do we have these images and what is the backend code looks like. This is my backend code. So we have basically two files. One is a YAML file and one other one is a JSON file. YAML file will basically contains all the images starting from Postgres and PGAdmin. As I said, this is completely optional. Zookeeper, Kafka, Debezium, and a schema registry. I'll come to later what a schema registry is. So Postgres, I am building an image based on the latest image from Debezium Postgres, and these are the credentials of the database, and PGAdmin in my local, and these are the credentials. PGAdmin is I'm hosting it in 5050 port, and Zookeeper, which is essential for Kafka. So this is Kafka topic, which can be hosted in 9092, and then the Debezium part, which is hosted in 8083. And the schema registry is coming from my Debezium JSON file, this is basically what is a schema looks like on my Postgres database. So we need to have it in a sequential manner, like image, Postgres image first, and PGAdmin. Zookeeper is essentially before creating Kafka, and then the Debezium comes part. So let's look at the JSON file as well. So I can have multiple tables in my database, but I'm particularly concentrating on only 2 tables. Even though I have 10 tables, I'm just doing my CDC replication and on 2 tables only. So this is my plugin name, database host, port, user, password, DB name, and the server name, and what I am particularly looking to do a series replication, which tables. So this is schema, public schema, and the claims. Save for drugs, public schema, and the drugs. So as we already created the container with multiple images, let's go into we can actually log into Postgres database using the CLI. If you can just click this one, it'll create a command prompt. You can just type PSQL and the database name, host name, database name, something like that. But I would like to I would like to give a more UI GUI interface. We can do it in PGAdmin. So let's open up a local host 5050 as a host in my PGAdmin here. And let's go and get the credentials. This is PGAdmin password, email, password is admin1234. So admin1234. So this is any PGAdmin homepage looks like. And to connect any database, create a server first and give a name like Postgres input and go to connection. Host name comes from the Postgres image. So if you see the code, the Postgres image name is just Postgres. And database is example DB user and password are Docker and Docker. So Postgres 5432 example DB Docker and Docker. Save it and it will automatically connect you to the database, example DB, schema, public. As we have not created the tables yet, you don't see anything here. So now let's just create the tables. So in the flow, I have already finished this step 2 as well. Now, before creating the tables, let's set the Debezium character. So this is the curl operation that we can execute and start connecting the Debezium to our application, Postgres database. Let's open the command prompt and just copy paste this one. Now see, it started to listening to any changes on the Postgres database. Now just create 3 tables. Even though I'm concentrating only on claims and drugs table, let's just create one more table and see if we are actually capturing the changes on the member table, even though we have not created. We are not supposed to, but let's take a look at it. So to create the tables, go to query tool and paste this one. Let me paste everything. Let me copy paste everything because we need it sometime later. Now create the tables. The tables are created. Let's just refresh it. And now you can see all the 3 tables. And we need to do a seed in order to tables are active for CDC. We need to do the replica identity full on each and every table level. I'm sure there'll be a process to do on the database level or on the schema level, which I don't know yet, So I'm creating multiple multiple steps to do on each and every table level. So let's run this one. So they are now ready for the series replication, all the three tables. But if you see my code, as I said, as I mentioned earlier, I'm just paying attention to only claims and drugs table. Now let's tail the Kafka topic and let's see the changes in action. I'm going to create multiple PowerShells. I'm going to open the multiple PowerShells command prompt and let's see each table level changes. So go to that folder, project folder first. And copy this one. This is basically a Docker run, which will tail the Kafka topic and connects to the Kafka topic and see whatever changes happening in a particular table. I will create the table here. So copy, first table is claims. Sometimes it will say the leader not available, but after we try again, yeah, see there are no changes yet is happening. The second table and the third table. So now all the three tables, all the Kafka topics. It's a single Kafka topic, but yeah, I'm just tailing into three multiple windows to see the changes individually. So offset 0 means there are no any actions yet. So now let's insert one row in each and every table. Now you see the claims table, there's null before and after we got a record. Supposed to be same on the drugs table, null and after, but we are not supposed to see anything on the member table because we are not capturing the changes into Kafka topic. So I just wanted to show you this one as we are not, even though we have table with the replica on, but we have not put it in our Kafka topic. We don't see any changes here. So let's close this one. And we already covered the step 4, and we are on the process of step 5. Sorry, I have to do it before. I have to come here before to do it in action, but yeah, I missed it. But we are in step 5 in the action of doing series replication. So the next one, there is our PG, yeah. So let's insert one more record in each and every table. You can see in the drugs table again, and the claims table again. So these are with respect to inserts. Now let's see how the updates works. See, the updates are working as like before we have this one with member 1, the claim ID 1. Now the claim ID 1, we have member 100. See, we have updated member 1, 200, and these are the changes here. And it could be same here as well. We have some data before, and it got updated. Let's do a deletion as well. So we have some value before claim ID 1, and after we have deleted, we have null. Here also same, before we have value, and after deleting, we have null. So this is how we'll capture the changes from a source database on a particular table level to a Kafka topic. And this the video is about. This is part 1 of my use case. As I mentioned, the part 2 of use case, I'll create that later, but that will cover how can we consume these Kafka topic changes into a target, whether it's a database or a streaming, or it can be anything, a GUI interface. So in my use case, as I said, I'll make a video to capture these changes in the target database. Thank you. I'll meet you in the next video.